Okay, this is how I drew my diagram, and you might have drawn yours, well, I'm sure you drew yours differently. So I'm going to first translate along AB and then along CD, and I'll call that A prime. So let's trace my figure and trace my translation vector. Okay, and I'm going to translate A there. Now I'm going to do this in one motion here. I don't need to draw the intermediate step. So if I now I take vector CD here and I translate my figure on CD, I get this image over here. So this is going to be my A prime. All right, I'm going to connect the dots for this triangle. Okay, so this is A prime. All right, so I did AB first, then CD. This time I'm going to do CD first. So translating CD would do that. And then I'm going to do AB. And translate along vector AB. And you can see that A double prime, or no, this is just A prime, again, along those two vectors, ended up in exactly the same location. Okay? All right, so let's, if you're unconvinced or you want to be really sure, let's draw two new vectors. We're still going to use A. Let's draw one right here. We've done A, B, C, D. We'll call this E, F. And how about one straight down like this? E, F, and we'll call this G, H. Okay, so I'm going to translate this same figure again. Let's do, so we're translating A. Now we're not going to match up with this A prime because we're using totally different vectors. But let's use FE and translate. We'll do FE first and then GH. Okay, so there's FE. And let's do GH. I'll bring it down. And there's our image. We'll call this one A double prime because it's with our second set of vectors. Okay. So there's A double prime. And then we're going to do those in the reverse order. So let's start again with A. This time we'll do GH first. That takes us there. And then we're going to do FE. And that transformation will take us right over to the same location. Okay, did you see that? FE, we slide it down, matches it up, exactly. Cool, isn't it? So you, if you answered number 7, you should have said, pause it if you haven't thought about it yet, but it says, does the same relationship you noticed in exercise 6 hold true when you replace one of the translations with a reflection? No. We already saw that in exercise 4 and 5 and in the example I did before that. It says, that is the following statement true? A translation followed by a reflection is equal to a reflection followed by the translation. No. And we can answer in a complete sentence. The translation, let's see, what do I want to say? Followed by a reflection would put, let's see, would put the image in a different location. A different location on the plane or something like that. Okay, a different location than the reflection followed by the translation. Okay, so that's pretty interesting, really. So what it says is that you have to pay attention to the order that you're doing these sequences of transformations in. And if something you're trying to do doesn't work one way, you could maybe try to do it another way. So let's talk about what we kind of saw in this lesson. So make this a little bit bigger. So we saw that a reflection across a line followed by a reflection across the same line places all figures in the plane back onto their original position. So in other words, a reflection undoes itself. And then a reflection followed by a translation does not place a figure in the same location in the plane as a translation followed by a reflection. The order in which we perform a sequence of rigid motions matters. So the order matters. Okay, enjoy this problem set, have fun, and we'll be back with lesson 9 tomorrow.